Hello interwebs, welcome to Let's Fix Computers. I've got a MacBook A1502 here, MacBook Pro A1502. So that's a 2015 Retina, and it does not charge, or power on for that matter. It would power on if the battery was charged, but it is not charging. So there's a little bit of history behind this laptop. It came in like last year, start of the year. I think it was last year actually. With the customer saying that it would not charge, and they had a genuine Apple charger. It's actually this one that I've got plugged in here with this mangled cable, and I was just like, oh, your charger's crap. But when I plugged in a different genuine charger, that one was also having problems. However, when we plugged in a fake charger would work, and this is kind of known behavior with Macs. Fake chargers and genuine Apple chargers have some slight different behavioral differences, which I'll explain more a bit later. But the point is, it would work with a fake charger. And I said, look, you can either we can use a fake charger and it will just work, or we can spend a lot of time and money investigating the problem properly. And she was just like, I'll take the fake charger. I'm like, okay. So I took a couple of fake chargers, off we went, all was well. But now it's come back in and it won't charge from anything. Won't charge from a fake charger or a genuine charger. So the problem has obviously progressed somehow. So let's roll the intro. We're going to open this up and take a look, and we're going to take a deep dive into how the MagSafe system works and the OneWire circuit, and how Apple MacBooks detects their chargers. So let's roll the intro and I'll see you guys in a moment. So before we get started on this one, I want to give a shout out to CMI Zapper because they've done an excellent video that covers how the MagSafe and the OneWire system works. And I actually rewatched that video before I started this repair just to refresh my brain on how that works. Because I've watched the video before in the past and I was aware of its existence. And when this one came back in, I was like, oh, I'm going to need to know this. So I rewatched that video as a primer. I will link it in the description because it's an excellent watch, and it will cover... I'm going to cover a lot of the beats that it goes into, but it's still an excellent watch and I highly recommend checking it out. And as well as if you're in the repair business, CMI Zapper also makes and sells various widgets that I use in repair, such as the Chipmunk USB tester, which shows activity on the USB ports that help you tell if a laptop is on or off, as well as if there is CPU activity. Likewise, I've got this HDMI tester. This one's been really useful. I haven't shown this one off much, but I use it for testing HDMI ports when I'm replacing ports on consoles like Xboxes and so on. Again, it shows you whether the HDMI port is active, if the device is on, if the data pairs are linked up, and so on. Very, very handy. And I've got a couple of other CMI Zapper widgets kicking around here that CMI Zapper very generously sent in. And I have found them very useful. So with that in mind, let's take a look at this thing. So the laptop has got some honest dust inside. We've got a third-party SSD in there for extra storage. I don't think that makes a difference to this, but we're just going to keep that in mind. And I think we're going to start out just by taking some measurements and just seeing how far we're getting with the power. Also, just to make sure that I'm not taking something for granted here. So this board is... I can't remember what number it is. The number's under this flex, I think. So let's just undo a bit more. Right, so down in the bottom left corner of the logic board, you can see that this is an 820-4924. So let's just bring up the schematics for that while I'm here. And we're just going to start by checking our main power rails just to see if it's doing anything at all. So I'm going to plug in the genuine power adapter. And we're just going to measure to see what power is coming out of that adapter. So the MagSafe port goes in this cutout area here, and it's got a cable that goes across to here where it actually plugs into the logic board. So let's check here where the power comes into the laptop and just see if the charger is actually on. So I'll measure that first pin. And as you can see, we've got basically no power at all. So that doesn't look very promising. So now I'm going to bring in what is effectively a fake Apple charger in the form of a MagSafe 2 that's plugged into a USB Type-C charger via the Paul Daniels meter. Now, this is where I'm going to just briefly explain the difference between a genuine and fake MagSafe charger. Now, MagSafe is not a hot plug connection. On a genuine charger, so this mangled one here, this guy is not always hot at 18.5 volts. It actually should sit at a low voltage. And when it senses a specific resistance from the positive to ground, when it detects a specific resistance, the charger will interpret that as I am plugged into something, and it will step up to main charger voltage. So that way, when this is not connected to anything, if you short across there, nothing will happen. Which is kind of important for this because you've got fairly exposed connectors there. Now, a fake charger does not respect this and is just always hot. And so in this instance, because this one's plugged into a Type-C charger, this is always hot at 20 volts. So theoretically, if I plug this in, we should see 20 volts at that same connector. So let's plug this in and see what happens. So the Paul Daniels meter is showing 20 volts. And at the jack, I'm still in resistance mode. And at the jack, we've got 20 volts. So there's 20 volts going into the laptop now, but we don't have a green light on the charger. So let's start tracing this into the laptop and seeing how far it's getting. So once we get into the logic board here, the first thing we're going to do is we're going to go up to this fuse here, F7005. So let's check that we're getting into this fuse and out the other side. So let's probe the output from there. Okay, and we have a blown fuse. I'll drop under the microscope just so I can show you that measurement. So here is where the MagSafe connector plugs into the logic board. I'll put my black probe on ground, and at the bottom of the fuse, as you can see, we've got our 20 volts coming in from the charger, and at the top of the fuse, we have nothing coming out. So that's why the laptop is dead now, because the fuse is blown. Okay, so I'm going to disconnect the charger at this point, and we're going to drop into resistance mode. So in resistance mode, once again, I'll put the black probe on ground, and we're going to check if we have a short circuit at this input. Which we don't. We're seeing 67 kilo ohms of resistance there. Now, remember that number, 67.6 kilo ohms. That will be important in a moment. I think that's a good number, and I'll explain as we get there. So let's follow this a little bit further in, because my goal is twofold now. There's a good chance that if we just replace that fuse, the laptop's just going to work as it was working before. But now I've got it under the microscope, we may as well look at this issue with it not working with genuine chargers anyway, and see if we can actually resolve that, because it's something that doesn't have to be resolved, but it should be resolved. So let's see if we can do anything. So if we right click on this fuse and hit search, so FlexBoardView finds it in the schematic, we land on page 53 here, and so here is the MagSafe charger coming in, and we go up here and we hit F7005, which is the fuse that has blown. So it's 6 amp 32 volt fuse, so you know it's kind of concerning that's blown, but we'll cross that bridge when we get there. So we're going to follow that all along the top here, and that comes down, and then it hits this spot here. So this is where it gets interesting. Right here we've got R7012, which is a 68k ohm resistor. So this is the MagSafe bit that I was talking about. Remember how we had 67.6 ohms? That is the resistance that we're seeing here. This resistor is here specifically so when a genuine charger sees that amount of resistance, it knows that it's plugged in and it should switch on. So what this tells me is that this resistor is probably okay, but also it's kind of concerning because it means that straight away I'm not sure why the other... Well, actually, no, we do know why the genuine charger didn't switch on. Is because the fuse is blown, so therefore it was not seeing that resistance. So that may explain why we had 0 volts from the genuine charger. Fine. Okay, so we'll come back to that one. So we go past the MagSafe. We go past the MagSafe resistor here. We come down here and we hit Q7010, which is a MOSFET. And we've got a resistor divider here, resistor divider that is setting the gate on this MOSFET. And what this means is that the small amount of voltage that is coming from a genuine charger when it's in standby doesn't go into the laptop because it doesn't get past here. It instead just goes straight to this resistor. However, once the charger is on and supplying 18.5 to 20 or 20 volts, it will set the voltage of this gate. This guy closes, switches on, and passes the voltage through. So now we've got voltage coming in to PP18V DC in isolated. And it also comes down here and it goes down to the PP3V42 power supply. So remember our MacBook basics, the 2 supercritical rails we need are PP-bus G3 hot and PP3V42. So you can see how the moment that charger voltage is getting into the laptop, the first thing it does is power up PP3V42 because this is needed for everything else to happen. So we're going to want to check if the voltage is actually getting down here and starting up this supply because we're not going to get anything without this. So we're going to check that in a minute. So once we've got this far, we've got PP18V5 DC and isolated, and there's these other stuff here, these bleeder sections. I'll be honest with you, I'm not sure what these are doing. It's not super relevant to where we're looking right now, though. So this is probably just various various protection circuits, or the way that it says bleeder. This might be there to just sap residual charge out of the circuit when the charger turns off or something like that. Speculating wildly. Now, what I'm going to do is we can't start measuring voltages because that fuse is blown. We can't really do anything with a blown fuse in there. But before I just replace that fuse and power it up, I'm going to check for shorts at PP3V42 and PP-bus G3 hot. So let's just check those. I'm going to head on over to L7095 because that's the output for PP3V42, and we're going to see if there's any issues there. So let's just find that on the board. That is on the back. Can we find PP3V42 on top of the board? Yes, that looks like there's a bunch of test points. So again, we're still next door to the input connector there. And I believe this test pad here is PP3V42. So I'm just going to check the resistance on that. And yeah, we've got like 55 kilo ohms. We've got multiple tens of kilo ohms of resistance. It's not shorted, is the thing that I care about. No problem. Okay, let's just check a couple of other places. So let's check PP-bus G3 hot, which appears at this current sensor resistor, which again is right next door to where we're working. So let's check that one. Oops. Yeah, we've got kilo ohms and rising there as well. That's okay. And just for posterity, we're going to check the 5 volt and 3.3 volt rails because that's a common failing point in these laptops. And if we had a shorted rail at some point, that might have blown a fuse on its way out. You might notice that the resistance starts low and then it climbs up. What we're seeing there is capacitor inrush. So where this laptop has been off for a while, the capacitors in it have all drained. And when I initially probe it with the multimeter, the power that the multimeter is passing through the circuit is getting sucked into the capacitors to charge the capacitors, or at least partially charge them. And so the multimeter interprets that as low resistance. And then as the capacitors charge up a little bit, their resistance suddenly drastically increases. So that's why it takes a moment. And this is important because if you have your multimeter in continuity mode, in beep mode, there's a very good chance that your multimeter is going to beep for a moment and then it won't beep. And you'll be really confused because you're like, what? It was shorted and then it wasn't shorted. It was never shorted, but because the capacitors were empty, for a moment your multimeter saw low resistance, which it will interpret as continuity. This is why beep mode is bad and you shouldn't use it, because it can deceive you. This plug here goes over to the right I/O board. I'm going to check the connectors over here because we've got the 3 volt and 5 volt rail here. And again, we've seen these guys do their thing as well. So I'm just going to check. One of these is ground, so I'm just going to find a ground pin super quick. Yep, so I've got my one probe on that pin and the other probe on a screw hole, and we're getting low resistance. So I think that's ground. And we'll just check that one. I think it's ground 3.5 or something like that. Yeah, second one, that's also ground. Next one. Eight kilo ohms, not shorted. And the top one. Four kilo ohms. All right. Those don't seem super high to me, but they're not shorted, so that's fine. So our 5 volt rail wasn't shorted. I'm just going to check. I'm just going to check the connections down here as well. So once again, black probe on ground, and we're just going to check these connectors. So we should have ground. Hello. There it is, ground. Still ground. Yeah, and then gonna call it 3. It might be 5. It doesn't matter. It just shouldn't be ground. Yep, high resistance and high resistance. Okay, so we don't seem to have any shorted rails in this. We've just got a blown fuse. It looks to me like there's nothing wrong with this laptop except a blown fuse. And that fuse could have blown for just any reason. Sometimes fuses blow. They fatigue, they thermal cycle. This laptop is 2015. It's, 8 or 9 years old. Maybe the fuse just died. So I'll tell you what I'm going to do. I'm going to replace that fuse and we're going to carry on taking voltages. I think this is a whole lot of nothing, and I think I'm probably exercising an extreme overabundance of caution. But if nothing else, I'm showing you where you can measure. I'm showing you the kind of checks that you can be doing to start looking at where problems might be in a laptop that's in this kind of situation. So take of that what you will. All right. Another thing to bear in mind is that if I saw any sign of liquid damage, we really should take the logic board out, but I'm pretty certain I can soldering iron hero that fuse and just not have to take the logic board out. So I'm going to continue to be lazy for a moment. So yeah, if you see any kind of liquid damage or belief that there might be issues underneath the logic board, you should take it apart. Right, let's turn this around so I've got slightly better access to that fuse. And I'm going to take that fuse off the board. So to remove this, I'm just going to stick my soldering iron on both sides of it, and I'm just going to nuke the thing off the board. I'm going to go in for the side swipe hit and run here. Here we go. Big old solder blob. Get both sides at the same time. Die. And I'll put a little bit of flux down and just clean those pads. Okay, right, now we need another fuse. I have a donor board here. This donor board is a 3476. However, over at its MagSafe connector, we've got what's going to be exactly the same fuse. So I'll steal it. No one will know. As a special treat, we'll make sure it works first. So let's just put my probes on both sides of it. All right, yep, we've got 0 ohms, or 0.4 ohms going through that fuse. So that fuse is intact. I'll be a little bit more gentle with it, though. There we go. Okay, let's just touch this pad with some fresh solder. Not you. In a moment. There we go. And we'll flow this guy onto that pad. Let's put a little bit of flux down there so we get some nice joins as well. Now, this guy is not going to be 100% flat because I didn't exactly clean the fuse first, but... There we go, that looks serviceable. And when you're doing this style of soldering, don't worry too much about the first join we've made over here. That's just to tack it onto the board. It doesn't matter if this is an ugly blob. What matters is that the component is on as straight as you want it to be. So you just need it to be stuck down straight. Then we'll just touch that other side. There we go. Right, now I'll clean my iron and we'll just touch both of those joints again and we'll try and get them nice and neat. As a special treat, I'll add some more flux. Alright, so now we're just going to do a little bit of a swipe. Nah, that'll do. And I'll try and get the back as well. I'm trying not to damage this connector. That will do. It's on. Plenty of solder on both sides. Let's clean that up. And then we'll put the power on and we'll see if it works. Now the question is going to be if the genuine charger works or not. If the genuine charger doesn't work, it doesn't matter too much because the customer has 2 fake chargers. But I would like to solve that problem. But also, you know, I don't know how much I super care. Right, fuse replaced. I'm going to connect everything on the right I/O back up again, just so the laptop is in what can be considered a normal operating condition. And I'll plug in a... Let's start with the genuine charger first, and let's just see how far we get. I don't think the laptop will turn on with the battery disconnected, but, you know, if we see it start, then so be it. Right, here goes nothing. Please don't blow up. I think there was a flash on the charger just then. Don't know what to make of that. Let's see if there's any voltage there. And we've got like 600 milliamps, sorry, 600 millivolts and dropping. I don't know what to make of that. Seems like the charger tried and then gave up. Let's plug in the fake charger. Right, that's giving us a green light on the charger. So, to all intent and purpose now, the laptop is ready to start. I'm going to check if we've got PP Bus G3 hot. I think we will do. So we'll go black probe on ground, and I'm just going to touch the current sense resistor for PP Bus G3 hot that we looked at earlier on. And we've got 12.6 volts. well, 12.56, close enough. And that is an active PP Bus G3 hot. So the laptop is working again, once again, only on a fake charger. So, okay, while we're here, let's just see what we can do about that. What I can assume from this is that the genuine charger isn't switching on. It's not seeing what it wants to see. So let's check the resistance on that line once more. I'll come under the microscope so you can see what I'm measuring. So when we connect the genuine charger, it's going to be looking for a resistance, and what it sees is nothing. Mega ohms? I'm sure we saw that 67 ohms earlier on. Let's just check it up here. Yeah. Odd. You guys can rewind the video. I'm pretty sure that we saw like 67 kilo ohms earlier on, because I specifically pointed it out and said, remember this, it will be important. I don't know what happened to that. Well, in any case, let's go and take a look, because my next move, even if we'd seen the correct resistance, my next move was going to be to replace that resistor anyway and just see what happens. Maybe it's just enough out of spec that the charger doesn't like it. So, let's go back to the schematics a moment. So, we are up here. We've just replaced F7005. We now have power that's coming down. It's coming down here. It's setting this resistor divider. It's setting this gate. It goes in. It powers everything up. The laptop probably starts. We should probably confirm this, but we'll do that in a moment. The fact that I have a green light means that we have PP3V42, because PP3V42 powers the LED in the charger connector. So this is definitely fine. And we checked PP Bus G3 hot, and that was up, and the SMC was running because it was at 12.6 volts. So we have all reason to believe that the laptop is fixed. So what about R7012? We thought I should have seen 68 kilo ohms when I checked the resistance at the MagSafe jack just then. So why didn't I? Let's find R7012. R7012 is one of these tiny little boys that was near to where we were soldering. R7012 is this guy here. So this guy here, that should be 68 kilo ohms. And it goes down to ground. So you can see here that the power comes in and there is this resistor down to ground, and then we go into this. This is probably that MOSFET, which is and actually it's definitely the MOSFET, because if you look here, you can see that we've got a resistor divider here, and there's that capacitor there, and there's stuff going on that's setting a gate voltage at this MOSFET. We've got an input coming into here, and then outputs here, and then it's going down through here, and it's going down through here, and it's going through all of this stuff. So this tiny little resistor here, this is the guy that should be telling the MagSafe charger to turn on. Is that actually alive? 67.5 kilo ohms. So why didn't I see that when I checked that up here just then? I'm going to try testing black probe on a screw hole. I'm going to measure that again. And now that's back. So I don't know what the hell is going on there. However, we're getting 67.5 kilo ohms, and we're expecting 68 kilo ohms. We're like 200 milliohms out, man. I can't see a world where that's the problem. But I tell you what I'm going to do. I'm going to swap that resistor anyway, because I don't have any other ideas, if I'm honest. I mean, what else could it be? You might ask yourself, okay, well, could it be finding some other path to ground? Well, in order to find another path to ground, it has to come down here to D7010. So we've got a Schottky diode down here, and this is or a Zener diode, sorry, and this Zener diode, this is in reverse. So as you can see, it's pointing up from ground. So this thing is doing nothing, and it's only going to conduct if something hits the breakdown voltage. So what this guy's going to do is it's going to provide protection in the event of, you know, overvoltage appearing here or something like that. Suffice to say, the easiest path to ground is still by going through this 68k resistor. Okay, I'll try changing it and I'll see what happens. If this works, then awesome and strange. If it doesn't work, I'm sending the charger on their way. I'm sending the customer on their way anyway. So let's change out the resistor. I'm going to start by knocking this one off the board. I can't see a world where this is going to do it, but sometimes you've just got to just try something out and see if anything happens. I'm going to do the same sideswipe hit and run method here. Oh, this guy is small. Might need to change down to a smaller tip for this, just so I can have some control. Ah, telephone! Alright, coming in with some smaller solder now. See if I can tin that pad. It's not going to want to go. Get some flux on there. I think I might be at the wrong angle to actually get the tip onto the pad. This is a pretty heavy power plane we're on here, so you can see that the iron is fighting me a bit. I'm going to have to give it some more power. I don't like driving this tip at higher temperatures, because it just makes the tip go dull, and then everyone shouts at me for running a really unclean tip. However, we'll make do. Let's just see if we can tack this guy down. Working on tiny components on big power planes is sucky. You need to put a lot of heat into a very small space, which is extremely difficult to do effectively. I'm just catching the back of the MagSafe connector there, which is unpreferable, but... Come on, please go straight. Oh. Nah. It ain't pretty. Let's tap the other end of it now. I'm going to turn around. Okay. Now I bet when I measure this, I'm going to see exactly the same resistance as I did before. And I also bet that this isn't actually going to work, but whatever. I tried changing this resistor, so if anyone says, oh, you should check that resistor, I can say, I did. Or it's going to work and I'm going to look like a genius. Alright. What do you say to that? I'm going to check it from up here so I can be certain that it's actually soldered down. Okay, we've got 68.4K. It's actually a touch higher than it was before. And like, I'll take that as a win. I can't see a world where 200 milliohms was the problem. But I think we're slightly closer to target now. 1% accuracy, who knows, who cares? Let's see if that works. Same thing. It powered on for a moment, then it died. I feel like there's something else going on in this laptop. and there's some kind of protection in the genuine charger that is detecting a fault condition that the fake charger doesn't care about, and maybe that blew the fuse. But at the same time, we've got it as far as working. It's probably actually powered up. Yeah, that's powered up. The CPU's producing heat. And that now it's gone off again because the lid is closed, but it's charging. Okay, well, I'm going to send this one on its way. I could spend, you know, I'm over an hour deep into this repair now. So at this point, to be brutally honest, I'm not quite sure where we're getting hung up with to get a genuine charger working on this. We've got R7012 is being set correctly, so we know that that's working. We know that Q7010 is activating because Q7010 must switch on in order for PP3V42 to switch on. So we know that that bit is working as well. If we weren't getting PP3V42, then that would lead me to believe that there could be issues with this resistor divider here. So, you know, this resistor was fine, but there's something wrong with these guys, so Q7010 doesn't switch on. But we know that this guy does switch on because we get PP3V42 with the other, with the fake charger. So I'm not sure what's going on there, quite frankly. And given that I know that the customer has knockoff chargers already, so they don't have to buy replacement chargers in order for their laptop to work, I'm not super fussed about solving this at this point onwards. If anyone thinks they know what this is, I'd be interested to know in the comments, because I jumped through hoops to try and solve this because I thought that would make a good video. But honestly, I'm not. I'm kind of stuck on this one, and I have something that does mostly work. So let me know what you think the problem is, and we'll go from there. Thanks for tuning in, everyone. I hope that was interesting, if nothing else, and I'll see you next time. Bye.